PFAS are everywhere. In drinking water, there are certain products that we use, and most likely in all of your blood you will find some PFAS if you test your blood for PFAS. And that really shows the problem that it's not only the ones who are exposed to PFAS like I was as a firefighter, but it's a concern for everyone. I just wanted to point that out. To underline a little bit the importance of this topic. Okay, talking about a little bit about some terms that I'm going to use, some abbreviations and definitions. I will talk, when I talk about foam, I will talk a lot about AFFF, and AFFF is the main foam that used PFAS, so PFAS-based foams often referred to as AFFF, but it's not technically not the same. Sometimes you also find something like fluoroprotein foams or film-forming fluoroprotein foams, and all these foams are also containing PFAS. So it could be AFFF, it could be FP, which stands for fluoroprotein, and it could be film-forming fluoroprotein. Just to be clear, because sometimes you lose it, but very often when we talk about PFAS-based foams, we only talk about AFFF. But what's really meant is all PFAS-based foams. So you see that right here, definitions. What you also hear frequently is like C8 and C6. C8 foams, C6 foams, or C6 PFAS, C8 PFAS, and that is really about the carbon atoms in the molecule. So C8 is longer than C6. So when you ever hear that, and sometimes firefighters refer to, oh, this is not a C8 foam, it's a C6 foam, it refers to the active ingredients in the firefighting foam. So you use a different active ingredient, a different PFAS for this firefighting foam. And I come back to that later to tell you why we're doing that or why the industry did that. And some other abbreviations, fluorine-free foam, PFAS-free foam, FF, triple F, 3F, SFFF, NFFF. There are a lot of words for PFAS-free foams, and the industry has not yet decided on what is actually the right term for the fluorine-free foams. So you can say fluorine-free foams, you could use any of these, and it's very, very confusing because, for example, if you think of SFFF or NFFF or triple F foams, we also have that in AFFF. But AFFF is PFAS-based foams, and all the other ones are fluorine-free foams. So it's a little bit confusing, okay, when talking about foams, or if someone tells you, oh, we're using this type of foam, it's sometimes a little bit confusing, okay, is it PFAS-free or is it not PFAS-free? But I'll also come back to that later, how you identify PFAS-based foams. Okay, how does foam work and why do you need PFAS in there? So let's start not with PFAS, but with some simple foam. And foams are just surfactants. You could actually use any surfactant to fight a fire, any surfactant that forms bubbles, which most do, or all do. So think of it, you have some washing detergent, some fairy that you use for washing your dishes. You could use that to fight a fire. So it's not very good, it's not very stable, the foam, but you could do it. It's fighting a fire, it's very simple, it's just something you want, and you separate the fuel from the air, from the oxygen in the air. And you use that in creating a layer of foam that you put on top of that. And basically you could use any surfactant to do that. So what do the surfactants do actually? So think of, you want to wash your dishes, you have a sink and you have some water in there and you put some surfactant in there, some washing detergent. And what happens, the molecules, they have one end that is hydrophilic and one end that is hydrophobic. In case you don't know what that is, it means one end likes to be in water and the other one does not like to be in water. So that's hydrophobic. And the place in your washing sink for these surfactants is basically on top of the surface, because then all the surfactants have the possibilities, all the molecules, to stick one end in the air and the other one in water. But at some point the surface is full, there's no space anymore for more molecules, so they will form something like micelles, which is actually what you want, because you want micelles to form to wash or to encapsulate basically your oil or your dirt in your dishes. But that's not what you want for firefighting. Actually, you want something else, because you want these active surfactants, and if you stir it, if you add some air in there, you will get some foam, and what you're seeing here. And that is because you have a lot of interfaces between air and water, and that's very nice for the molecules, because they have a lot of possibilities, not only the surface of your sink, but you have a lot of possibilities to place them, and you will actually have a lot of molecules which are in these these bubbles between water and surfactant premix and air. So that's why you get foam. And actually, if you want to wash your dishes, you don't want to have foam. And actually, when you want to have foam, you don't want to have micelles. But that's a different story. Okay, so this is how foam works. Now, this is not about fluorinated surfactants yet. Fluorinated surfactants come now. And they give a little very good qualities, and the reason for that is explained in this drawing. And it's a little bit dark maybe, so what you see in here, these are the bright white surfactants, but you also see some red in here, so I don't know if you can read that very good, and there's some blue in here which says water film. And actually, when we're talking about PFAS-based foams, we're talking about AFFF. AFFF stands for aqueous film forming foams, so they form the water film. So why is that good? So think of it, you want to put out a fire of some oil, and normally the oil is lighter than water, so if you want to do that with water, it doesn't work, right? So you need the foam because it is lighter than the oil. If you just use water, the water will sink and you don't get a very good extinguishing effect. So, but when you add to your normal surfactants, if you add some fluorosurfactants on it, fluorosurfactants have a very special property, and they have one end of the molecule which is hydrophobic and lipophobic at the same time. So it doesn't like oil and it doesn't like water. So what happens? Your normal surfactants are here at the bottom, they are in the fuel. So think of like benzene, diesel, oil, and they stick one of their ends in there because this is hydrophobic and lipophilic, which means it likes oil, it doesn't like water, and the other one is the opposite. So it likes water, it doesn't like oil. So this in here. And then you have your fluorosurfactants, and your fluorosurfactants, they don't like water and they don't like oil, so the only chance for them is to stick their other tail in the air. And in between, you have a water film. And think about what a water film that actually floats on top of oil does. It's very nice because water flows very good, so you get a very good extinguishing effect. Foam flows, it's okay, but water flows even faster. So you're actually putting a layer of water on top of your oil, and that is a very fast extinguishing effect. It's actually that good that you don't need the foam that much. So it's really the water film that helps you to put out the fire, not so much the foam. The foam comes on top of that. That's okay, it adds to that, it gives some stability, some insulation from flames and heat and so on. But actually, it's a very good effect, only this water film. Now, and this is important for later, once you don't have fluorosurfactants anymore, and now we're hearing in this workshop you can't use or you shouldn't use PFAS anymore, so you don't have any fluorosurfactants, so you don't have any water film. So that means you don't have this aqueous film forming foams, you don't have a water film, you need to think of how to create an extinguishing effect without PFAS, and I'll get back to that later. So this is basically the extinguishing effect. You have some oil in here, you have some bubbles, some foam on there, but you have this water film which is ahead of the foam actually and puts out the fire first and seals it and prevents vapors to be released. So that is why AFFF are very good. Now we need to talk about some other things. So if you don't have fluorosurfactants, if you don't have PFAS anymore, you don't have this water film, but still you have some foam and you use that to put out the fire. And also very important, if we're talking about polar fuels, so think of ethanol or methanol or everything that mixes with water very well. That doesn't work with water film, right? Because the water film would be destroyed. So once you're thinking about ethanol or any alcohols or any polar substances, you never needed PFAS-based foams in the first place because your water film doesn't help you in any way. What you need is like a polymer film. That's a different story. So you add some polymers in your foam concentrate to create a polymer film. But nevertheless, you also can get AFFFs, which are alcohol resistant. So you add some polymers to AFFFs and you get an alcohol resistant AFFF. So technically speaking, you never needed PFAS-based foams to fight polar solvent fires in the first place, but very often the industry did because it was thought of the best, and you can get it as an alcohol-resistant foam, and it just was used as such, although you never needed it. Okay, some types of foams. So this is a little bit technical, but you can make foams of proteins, or of some synthetic surfactants. So in the early days, we all used not me because I wasn't born then. But protein foams were the standard types, and then at some point, AFFFs were developed in the 60s, 70s of the last century. So that was really where we are coming from. And compared to protein foams, these PFAS-based foams were really a game changer. They were really that much better. And now we're going away from these AFFF. We're still basically using synthetic foams, so we're using synthetic surfactants, but with a much higher performance. So not me, but the industry really developed some new types of foams which are compatible or comparable with AFFFs. Not in the effect, or not in the way they extinguish, but in the way they perform. Okay, how do you find PFAS-based foams? And that's really difficult, and it's also a little bit difficult because so far, when we talk about Stockholm Convention or when we talk about what the European Union regulates through REACH, it's not that they ban all PFAS, right, as a group, not yet, at least. And we'll hear about that, I think, a little bit more. So we have like a substance by substance approach. And because the industry, when one substance is banned, like PFOS, that's the first PFAS, so PFOS is one PFAS. When PFOS was regulated 10, 15 years ago, the industry came up with some other solutions for that. They just use different kind of PFAS. So that's why it's all a little bit complicated. So what is allowed, what is forbidden, how can you identify that? So whenever you look at some warehouses or some stores, some fire services, and want to see, okay, you're using firefighting foam, is that PFAS-based foam or is it fluorine-free foam? So maybe first let's talk about where do you find that. So basically you need firefighting foam to fight liquid fuel fires, right? So you want to use it for that. That's the main purpose of firefighting foam. So when you want to know where do I find it, who is using this type of foam, think of the fire services, of course, because they will have some liquid fuel fires they can encounter. It's not the majority, but it can happen. Think of airports, because they have the jet fuel, and which is a high risk. Think of refineries, which process a lot of large quantities of liquid fuels. And then some other industries that could potentially use, for example, think of fixed extinguishing systems, like a sprinkler system. Sometimes you have that in hotels, that's all water, but if you want to protect a hazardous materials warehouse somewhere, and you want to store some chemicals, like chemicals for, I don't know, for some processing, for some industry purposes, like for any purpose basically. And you want to protect them, you can have a sprinkler system and you can have added firefighting foam to that if you have large quantities of these chemicals. And then in some other cases you will find them whenever you use oil, like large quantities of thermal oil, large quantity of hydraulic oil. In some industrial processes you can have that. So we have clients who use it for wooden chipboards, right? They produce chipboards, but to produce them you need like a lot of pressure, and this pressure comes from hydraulic pressure. So they operate large quantities of hydraulic oils, and they protect these hydraulic oils also because they are heated, and they protect them by a fixed extinguishing system, and that uses foam. So sometimes it's like thinking about, okay, who could use firefighting foam, and it's very often like, okay, everyone who is using or who has the risk of liquid fuel fires. When there are some more applications for firefighting foam you need to think of, but normally they shouldn't use PFAS-based foams. So, for example, for wildfires, you could add some foam in there. It's basically to decrease the surface tension of the water so that it can better get into the surface of certain things. So you can add firefighting foam for wildfire fighting, so like forest fires or whatever you have. But that is normally, typically it should be fluorine-free foam. You cannot be sure 100%, but it could be used for these aspects. And also for all other solid fires, like class A fires, you could use firefighting foam. Sometimes it is used, but not very often. So these are the industries where you could find firefighting foam. So once you're there, you want to make an inspection maybe and want to check, okay, what kind of foams do they use? You will see some containers like these. These are the original containers or pails from the manufacturer, and you will see something like aqueous film forming foam. Okay, that's AFFF, that's an indication of PFAS-based foams. It says here fluoroprotein, okay, fluoro, okay, that's for sure an indication that this is PFAS-based foam. Actually, I cannot even see it anymore. I think it says like FFFP, which stands for film forming fluoroprotein foam. I think it's even alcohol resistant. So this is PFAS-based foam. And then you will find some other, maybe some more detailed indications on these sheets, or this is a tank from a fixed extinguishing systems. Maybe there's a data sheet on here. Sometimes you cannot really tell. So what we always do, we take a sample, we send it to a lab, we analyze it for PFAS, and then we know for sure what is in there. So this is like all the labels, that's the first indication. So that gives you a hint. And then we take a sample. And then we get results like this. And this is also quite interesting because some PFAS are banned, some are not, or most are not yet. But we need to understand, okay, how does it affect our firefighting foam, what is forbidden, what is allowed, and you get results like this. So this is, so first, we just heard from Daniel, you have like thousands, like 10,000s of different PFAS, but the lab result will give you like 20 or 15 results. The other ones are all unknown, we don't know them. And we cannot analyze them, and even the labs cannot. I mean, some labs can do like 40 or 50, some are very focused on that, but most give you around 20. And what you're seeing here is like some very relevant PFAS. For example, PFOS. I don't know if you heard about PFOS before. That was the first PFAS that was regulated through the Stockholm Convention. And then you have some other PFAS like PFOA, A2FTS, PFHexS, and some more in here. And these are the foams. So we have like 4 different foams. We have a C8 foam, a C6 foam, a pure C6 foam, and a fluorine-free foam. Though, okay, quite easy, fluorine-free foam, it doesn't contain any PFAS, although we have to say it doesn't contain any PFAS above the threshold limit. Okay, so you have always a limit of quantification in your analysis, and this is, in this case, it's 10 micrograms per kilogram. So this tells you, okay, it doesn't contain more than 10 micrograms per kilogram. When you want to analyze water, that's a little bit easier. You will get a lower limit of quantification, but because it's a very complex matrix, the firefighting foam, you won't get a limit of quantification below 10 in most cases. Sometimes you get even higher, so you will have like a limit of quantification. Like in this case, you have a limit of quantification of 10,000, which is quite high compared to 10. Okay, so fluorine-free foam. Let's look at these foams. And again, C8 foam, C6 foam, that refers to the molecules. So this is like PFOA, and you count like 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms in the molecule. So that's a C8 molecule. And if your foam contains, or is based on an active ingredient with a C8, it's a C8 foam. That's what we call it. So take this foam, that's a C8 foam. It contains PFOS 11 million micrograms per kilogram and some other stuff in here. So this one was the first kind of foam that was regulated. The limit value in the European Union for that is 10,000. So you cannot use or sell or produce any foam with PFOS that has a PFOS concentration more than 10,000 micrograms per kilogram or ppb. But once this was banned, this was, I don't know if you ever heard that, it was produced by a foam manufacturer called 3M, so quite known chemical company, 3M, and they called their foam, by the way, light water because it was lighter than water. No, sorry, it was light water, but it's lighter than oil. Okay, so in parallel there are some other manufacturers, and they use the C6 foam. They didn't use PFOS as an active ingredient, they used something called Capstone A and Capstone B. And Capstone A and B are actually like commercial product names, brand names for PFAS produced by DuPont or Kilur. So they sold, I think they split Kilur out of DuPont, and they're now and they use Capstone products. By the way, just if you're really into that, Capstone, Kilur announced that they will stop producing PFAS, I think summer this year, so you cannot buy it anymore. Which is also a big problem for supply if you still need it, but nevertheless they stopped, or they will stop production. So this foam, it used Capstone A and B, so it doesn't contain any PFOS, so it's good. After the PFOS ban, you could still use this foam, no problem at all, no PFOS. And then a couple of years later, there came like a PFOA ban. In the European Union was it introduced first, and then it came through the Stockholm Convention, so it affected the world. And quite interestingly, it's quite low in here. It's not as much, it's not like 11 million or 50 million micrograms per kilogram, it's only 1,500. But it was a byproduct when it went through production of the PFAS, right? It was unintentional. And now, and I'm not too much into details, maybe you talk about that later. The Stockholm Convention says normally like, okay, unintentional trace contaminant should not be regulated or should not fall under the Stockholm Convention. I'm not a regulatory expert on that. But nevertheless, you need to know, okay, what is unintentional, what is not. And the European Union made a definition. They said like, okay, we can't really tell, so we set a limit value. We set a limit value for PFOA, and we set it at 25 ppb. So that means you can't use this foam anymore because it's way above 25 micrograms per kilogram, so you cannot use that anymore. But you can produce this type of foam with a higher purity. So the manufacturer, the raw materials manufacturer said, okay, PFOS now banned also, so we produce pure C6 foam. It contains still the capstones, but it doesn't contain PFOA anymore. So this is what you can actually, in the moment, you can buy right now. And whenever you see something like in here, it says, abort please. Okay, sometimes they have a label with C6 foam. Can't find it in here. Okay, sometimes this is like C6 foam, they advertise that, and you can still use that because it doesn't contain any PFOS, it doesn't contain any PFOA, at least not about 25 ppb. And it doesn't contain any other substances like PFAs, which is also bad. But now the European Union is preparing further regulation, and they want to ban all PFAS and firefighting foams. So this will fall under this because, of course, these are all also PFAS. One important note that I need to add to this, because we don't know all the active ingredients, it's kind of trade secret, so we don't know what is in there all the time. There are other active ingredients, so there's, for example, one of the big manufacturer of raw materials, apart from Kilua, and that's Dynex. And partly we know what they are using, at least in some cases, and sometimes we can analyze it for, but in this analysis you can't find that. So you could have even the case, you could theoretically get a result like this, and it's still a PFAS-based foams, just because it contains PFAS, we can't find that. We call that sometimes dark matter, because we don't know what it is and we cannot analyze it for. Okay, so that was all from me for the moment.